make our way back from the peak of COVID a couple of weeks ago. So it's a pleasure, Tim, at the last minute, agreed to come give this talk, and it's a real pleasure to have you. So we're going to go back and forth. For the virtual, I'm here and watching the chat and also watching hands. And so if Tim does not recognize your question, just put up your virtual hand and I'll interrupt it to get your question as well.
Yeah, please. It'd be great to have a conversation. It's nice to see so many of you. It's also great to be giving a talk in person here at HBS, and I hope we figure out how to do this.
But for the rest of us, Tim, can you talk loudly?
Sure. Okay. Let me try to just shout if I'm not coming through. So this paper is joint work with Bernard Gangelmeyer and Emma Tarantino at CEW and Luis, respectively. It's a paper that stalled during the pandemic, and we're pleased to be kind of trying to resuscitate it, just like we are with seminars. And it's called "Learning When to Quit." I lost my. I'll just use this. Oh, come on. Sorry. Technical difficulties. There. So there's a few ways to motivate this paper, but let me start with this one. Kind of lots of R&D or innovation or invention processes involve lots of failure, right? So there's this quote by Thomas Edison about trying to find the right sort of filament for the light bulb that I like. He says, "I haven't failed. I've just found 10,000 ways to do this that won't work." And this tweet comes from the Canadian Institutes for Health Research. It must be a great idea because it got 3,000 likes. It says, "How science works: fail, 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 succeed, fail, 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 and so forth." So you only succeed every once in a while. Lots of our research, where R, I guess, refers to the sort of like economics of innovation community, has this flavor. We take a set of papers or a set of patents that are the rare successes from that process, and then proceed to study. Either we sort of just normalize, we get some measure of inputs, and we just like take a ratio of inputs to outputs to get a notion of productivity, or we study what happens to the successes. And this paper is kind of about using standardization data, right? Data from the Internet Engineering Task Force, where you see the whole thing, to try and get a little bit of a better handle on the experimentation process, right? To abuse the metaphor one more time, it's like looking in the black box of how people experiment, in this case in standards development. Okay, so what we're going to try to do is we're going to study learning in the context of specification development at the Internet Engineering Task Force. And given the people I saw on the call, I think we'll spend a lot of time talking about IETF and what it does in the institution, because I think that would be of interest to you. There's a whole part of the paper which is also about building sort of a tractable structural econometric model of the learning process, which is important, and I'll talk about it, but I probably won't dive deep into the details of that. Fundamentally, what happens in the IETF, look, the engineers there, and they are engineers from kind of academics and many companies that build internet infrastructure, they experiment with ideas in kind of a collaborative setting. Okay, and what's interesting about the data that we have is it shows both the cases where they succeed, which means they publish their new ideas as something called an RFC. Important RFCs are things like the TCP/IP protocols or session initiation protocol that you use to like set up a streaming session. All of this sort of, not all of, many of the key protocols that make the internet work emerge and are first published as these RFCs. But we also observe cases where their ideas are put into the process and they eventually just get abandoned. So you can think of this as like sort of at the level of the teacher trying to sort of reach a consensus amongst a community of engineers on whether or not to sort of go ahead with a new feature for the internet infrastructure.
And success here does not correspond necessarily with value, because you don't see usage.
Eventually, well, we're going to use non-patent prior art citations as our proxy for that. So we conditional on publication. Then we go look at how many patents cite the RFC as our admittedly rough proxy for kind of like commercial use. You know, I'm
I
confident
see where you're going. Okay.
we need something, but you're completely right. Publication does not imply utilization.
Yeah. Okay.
Okay, so that's where we're going. Just to sort of put a finer point on like what questions do we ask? We want to know something about the anatomy of the experimentation process. Like, how do engineers come to success or failure? Like, you know, how are their beliefs, right? You would never start a research project that you thought was going to fail. So something must be changing over time as they do this experimentation. And we try to develop a model of that. And then we use the model, right? The point of the structural model is we can't see people's beliefs, right? You need a model to elicit those, to sort of recover an estimate of beliefs. So that's what the structure does. And then we can use it to sort of ask some interesting questions. One is like, what's the share of good ideas that don't make it through? Like ideas that could have been publishable, the kind of false negatives in the research process. Okay, and another one is we correlate our estimates of the speed of learning with things we can see, like how much communication is going on, how much experience do the engineers working on a given project have in the IETF, or going back to my job market paper, measures of conflict, what I many years ago called the suit to beard ratio. And then we do some counterfactual stuff too, which maybe I'll get to at the end. Just to preview the findings, what do we find? So we start with just like a descriptive analysis of the data. I'll tell you how the IETF works, and then it turns out that like around 75% of the ideas that are initially proposed to the IETF are abandoned. And almost 40% don't even get one revision, right? They're just, thrown out there and then people walk away, okay? We also show you that projects that get more investment in the sense of they're revised and revised and they're revised before they publish, they change and they have greater impact in these citations, okay? And the sort of descriptive analysis suggests to us that consensus, like what you need to publish, like success here is achieving consensus, okay? Consensus in our minds can't, given the descriptives, it doesn't seem like consensus yields immediate publication. This is, and I'll talk a little bit about how this process is really different from learning and experimentation in pharma, which is often kind of our default mode of thinking about this. Like I think people have notions of experimentation leading to sort of bad news. This is more of a good news kind of a learning process. You learn that you're going to get your idea sort of certified by the IETF. In our sense is that you need a model that has two stages. So how would that model work? It's going to be a stage of kind of trying to achieve consensus, and then a stage of trying to polish your idea to the point where it's ready for publication. So we estimate that model, the parameters that are not, observable to us in the data, but that our model reveals are, the headline ones would be about 60% of the ideas that we think, sort of initially proposed are good ideas. Like our model just has two types of idea, good and bad. Good being, publishable. But it takes you a long time to realize it, okay? Like you only have a 20% chance with each revision to kind of realize like, okay, there's gonna be a consensus here. So that implies actually quite a lot of abandonment of, potentially good ideas. Okay, and then when we go to the observables, we see that like there's some kinds of evidence that you would find, I think, kind of, I don't want to say confirmatory, but like consistent with priors. Okay, like this learning parameter, the 17%, that's going to go up when you have a more experienced team. It goes up when there's more communication. It goes down when we have these, kind of committees that are evenly divided between academics and commercial participants in the IETF.
And that'll be sort of your productivity equation.
Yeah, right. The productivity is on like the 17%, like pushing that 17% towards one is research productivity.
Yeah. Okay. Yeah.
Well,
Hannah has a question.
I have a question. Yes. So do you have some characteristics of good ideas? And what I'm getting at is there is this kind of expectation that if we are looking for consensus, among good ideas, the outliers that are more innovative actually are not going to go through, and therefore they will be abandoned earlier on, and only the kind of more mediocre good ideas are going to go through the process. Is this something that you are finding in any shape?
I don't want to overclaim. I think that's plausible. I don't think we have a lot to say about it. We do not have a ton of heterogeneity in goodness, right? Like we have these measures of citations, which are clearly endogenous to getting like the success, right? Like so ex ante quality of ideas, you can't, if good ideas are abandoned, the abandonment affects our measure of quality. So it's hard to disentangle, and we don't do a lot of heterogeneity on the quality of the ideas. But let's go, when we get further along, let's come back to it. I think it's a reasonable question. Like so many innovation processes, this is one where the outliers produce a tremendous amount of the value. Yeah.
Quick question. When you say publication, are you just meaning RFC? The publication is an RFC. Okay, got it.
Yep. Yeah. Let me, quickly in terms of like what literatures do we contribute to? One is like this econometric, we have a discrete choice, like a dynamic discrete choice model of experimentation in R&D. Those are sort of rare. Like my sense is there's a literature that has been these dynamic discrete choice models with learning. They've all been applied to marketing scenarios. Like, do I learn if I'm a good match with my toothpaste? And then there's been learning in the economics of innovation, like Ramana's stuff, and going back to Ariel Pekis and Josh Krieger's recent work, which is reduced form. Like I found a good natural experiment that shows somebody learning something. Ours is probably closest to this job market paper from last year by, I can never pronounce her first name, but Khmelnytskaya, on learning and drug development, which does this neat thing of trying to sort of figure out whether terminations of drug development projects are scientific or strategic. Like basically, is it that we failed in the clinical trials, or is it that I pulled the plug on my line of research because I can see that there's not enough market potential to justify the remaining R&D investment? So I think we're kind of close in spirit to hers, but ours is a single agent problem and she's got strategic interaction. We contribute to a literature on standards, which is, I think, kind of core to this community. So going back to Shane and Paul David, many of my prior papers. And then I think I like to sort of draw an analogy between the false negatives, or the cases where we think there's a good idea, right? Our estimates at the end of the day imply quite a lot of abandonment of potentially good ideas. And there's a neat parallel here to sort of the recently famous missing Einsteins, and sort of we're missing a lot of potential too in the way human capital translates into innovation. Okay, so now let me tell you about the IETF. Some of you probably know a ton about the IETF, and others this will be novel, and it's interesting, I think. So the IETF is a organization which is arguably the main forum for internet protocol development. Anyone can participate. You're an IETF participant if you join the listserv and start posting email messages to it tomorrow. In practice, sort of is largely composed of corporate, academic, and individual engineers and computer scientists. Why are they there? They're there to sort of advance technology in some sense. There are also, no doubt, underlying kind of commercial goals, right? So one of the biggest participants is Cisco, who likes to see advancement of internet technology because they sell routers, and, sort of moving from 1 gig to 10 gig, sort of causes replacement of the installed base of routers, and that's a good thing for Cisco, okay? But that's an indirect kind of a commercial benefit, right? A lot of what's going on here is engineers who are trying to sort of make new features and improvements in old features sort of at the core of what makes the internet go.
So if I'm an engineer at Cisco, do I join in my own free time, or is it part of my job?
The question was, am I doing this for my job or on my own time? The answer is mostly on my job, right? So the folks who are participating from Juniper and Huawei and Cisco and Ericsson, those folks are paid, and a large chunk of their time is they're covered by their employer. It was, we talked to, you have to convince Cisco that it's a good investment. So the engineers that I've talked to who are active participants, they want to do this also because it's a real feather in your cap as an engineer. It's interesting work and it gives you high visibility. But you still have to go to your manager and say, look, it's great. We need to build security into the internet, sort of I'm going to do security at the routing layer. This will be good for us. You should give me the time to do it. Okay. So here it says that the IETF is largely a decentralized platform, which means the ideas kind of for how to evolve internet technology come from there's not a architectural vision at the top of the IETF. Rather, people propose new ideas, okay? And those ideas sort of get looked at by folks called area directors, right? And their role in part is to just block projects that would be in conflict with one another, right? Like, so the IETF doesn't sort of have 10 versions of the same idea going at the same time. They'll form a working group to say, let's hammer out a solution, a standard on session initiation, okay? And that might lead to a single protocol. That doesn't mean that there's never sort of some competition amongst projects, and that's something that won't really be in our model. But it means we think that, to a first order, the IETF is trying to get people into a room to sort of agree on an approach. And so what you see is sort of a process of experimentation and development rather than competing proposals all the time. Okay. And then sort of almost most importantly for this paper, IETF has a super transparent process, which allows us to use this kind of data in the way that we do. They have a repository where every version of every project and its success and failure is observable. And they have these public email servers where all the communication occurs and you can go scrape those. The piece that we miss in some sense in terms of looking at their work process is what happens at meetings, right? Like they're a community that before the pandemic would get together 3 times a year and have these huge meetings. Because of the way they work, actually, the meetings would involve actually a lot of engineers showing up and communicating with each other over email. So it's an open question how much we miss.
I'm sorry.
Yeah.
This is another question around sort of the transparency, because if I'm an engineer and I'm working for Cisco, at some point Cisco is going to tell me, actually, don't put these in the public domain because we want to patent this. So are you worried that for some projects you're missing information that is proprietary to the company that these people are working for, or no?
I think what you're saying is right. So I was actually just talking to Frank Nagel about this idea, like how do they make money? Okay, so let me do a detour. I think there's basically kind of three ways you make money here. The first order one, this goes back a long ways in the standards community. They say, we cooperate on standards and we compete on implementation, right? Which does mean Cisco, and Cisco will acknowledge they do this, they hold out what they think of as implementation technology. So they design a standard which is public. So I'm not worried that in some sense we're missing something that's public, that's free. And it's just that Cisco probably has preferences over the direction the technology takes because sometimes it's going to work better with their proprietary complementary stuff. And other times it will work less well. That's kind of the mode here at the IETF. There are other standard setting organizations where the business model is cram your IP into the standard and then license it out. Okay, so that produces somewhat different dynamics, but that's a different, I think is probably better said to characterize like standard setting for cellular. And then the other mode is like there's, you can do sort of things in between. Okay, or open source, like, sort of commitment to free. Okay, so these are just, here's some examples of important protocols. I think it's important to say that a big protocol like HTTP or IPv6 is comprised of many, many of these projects that we're going to look at, right? So the IP protocol will have, it might be comprised of 10 or 15 RFCs. And we're going to see that, like only 20% of the internet drafts become RFCs. So it's like 100 projects in our data roll up to one of these big protocols. So you can think about what we're looking at as like feature development in a sense. Okay, so here, finally, how does it work? Here's the flow chart of their process. Let me try to step through it one at a time. So first, somewhere out there in this kind of decentralized setting, people come up with a problem or an idea and they submit a proposal. And in the language of the Internet Draft, language of the Internet Engineering Task Force, a proposal is an Internet draft, or we'll sometimes call it an ID. And basically there's two types. All of them come from individuals, but some proposals go into a working group, whereas other proposals are sort of individual ideas in search of a working group. And we'll think of those as different. We'll show you that things that are in some sense certified by having a working group immediately, learning is faster, or there's a higher probability of success and so forth. Okay. And then we should also think about there being two tracks. They call them standards track and non-standards track. And you can kind of see here that these requests for comments, they break up into three groups. There's what's called a proposed standard. Proposed standard means it's like a normative, like you shall design your product this way. Like if you want your router to work with the other guy's router, they have to set the same bit to the same value when they want the same functionality. That's a standards track proposal. And the non-standards track are these informational and experimental. You can think of them as not normative, but providing guidelines and like learning about how to do this well. It's kind of complementary knowledge, but not prescriptive about product design. Okay, all of the projects go into this public repository here called Internet Draft. Okay, so then what happens? Then they talk about it. Okay, the engineers say like, this is a terrible idea. This is a great idea. We need to do more of this. Somebody from Cisco says something that might be motivated by the fact that they want it to work with their proprietary complement over there. Someone else has a different idea. So all this is going on by email and at meetings. And finally, we get to the point where there's either a rough consensus or not. Okay. If there's a rough consensus, the project will eventually be published. Okay. It's going to go into this top box. Okay, what does it mean to have a rough consensus? Ultimately, that decision falls to the working group chair, which gets reviewed by this steering group. Really means that there's de facto a supermajority support, right? The IETF guidelines say this way. They say, any strongly held objections must be debated until most people are satisfied that these objections are wrong. Okay, so it's kind of a consensus decision rule, but not a unanimity rule. Okay, and so that's what happens if you get to a consensus. Suppose there's no consensus, right? Like we go down, instead of this branch of the tree, we go south. Then there's a decision, okay? Sort of the team of engineers working on a project can either say, okay, let's try again, let's revise it. And if they revise it, we just flow right back up here into the repository and the whole thing cycles, just repeats. If they don't revise it, they can just quit, okay? They can quit, and in 6 months, the thing is taken out of the repository, it becomes an expired Internet Draft. Okay, so that's at a high level, that's kind of how the IETF works. Anita, you just threw a question in and it disappeared.
Yeah, I was just asking if there's any heterogeneity across the working groups, in their composition or in their incentive structure that could, interfere with the scientific merit as the primary basis of their advancing the idea.
Totally. In some sense, the way you should think about our model, it's going to be very reduced form, right? We have a learning process. What are they learning about? They're learning about consensus. Am I telling you that consensus equals scientific merit? No way. Consensus is just the absence of sustained opposition to moving this proposal forward. Sustained opposition could happen for commercial reasons. It could happen for technical reasons. It could happen because you have a cranky bunch of engineers.
Can I follow up on Anita's question? So this is also not exactly a model of explore exploit. It's a model of novelty refinement. If
it's actually going to be both.
Okay, please.
It's going to be very explicitly both, right? Like, so the first stage of this model is explore exploit. You either explore by continuing to sort of test, right? Like every time you submit a new draft in our model, that's an experiment. You're experimenting and sort of updating your beliefs. Can I get to consensus or can I not? Can I get it? Let me try again. I don't have consensus yet. Let me try again. That's exploration.
Yeah, that's exploration.
Okay, exploit is quit. You know, this is a two-armed bandit. There's only one arm, which is keep trying or quit. That's explore, exploit. The second phase in our model is going to be like, oh, I got consensus. Now let me polish up the idea to the point where it's.
Oh, that's refinement.
That's refinement.
Refinement to publish. I see.
But it's not even at this stage, it's not even missing Einstein's only, it's also missing Steve Jobs's. Like it's missing incentive alignments as well as missing scientific breakthroughs, right? Potentially, if they don't move them forward.
Yeah, at one point we had in a presentation, we had missing Donald Knuths, but because it's not Steve Jobs, it's more Donald Knuth here. But yes, I think that, you know, sort of, it's different. It's a standard setting process, right? Like, so really, I want you not to be thinking about what we're learning here as it's not at all like pharmaceutical trials, clinical trials, where they're very much designed to reveal novel information about essentially efficacy and safety, right? Like it's not technical characteristics, although for sure, some of what's happening is debate about the technical merit. There's also a political process, okay? And so you're learning about both things. And maybe a different analogy, which is imperfect, is our own way of publishing. This is not like our own publishing process in that you can revise and run. You're never forced to quit. The journal never says no. But I think most of us view the referee reports as providing some grab bag of information about the political palatability of the things we have to say in our papers and the technical merit of the work that we've done. And I think that that's a not unreasonable way to think about what's happening.
There's an additional thing going on. Sorry.
Yeah.
There's an additional thing going on here, which is interoperability. So which they can anticipate. So you're only going to observe proposals that someone has anticipated have an opportunity to be interoperable with the existing really vast, at this point, vast set of protocols. And that's going to, right, that's going to give, selection bias isn't quite the right word.
Yeah.
It's going to call the set of things you're going to see. Whereas the academic one, there's still opportunities to be outside of, to be in conflict with existing installed base of ideas. You don't have to be interoperable. And so interoperability imposes some constraints, some serious constraint here, and an anticipation of it in particular.
Yeah, I think of that a little differently, but I agree. It's like, it's more that there probably is selection on there's upfront selection on anticipated consensus of, generating consensus, right? Like, so if you think all major players are going to be in opposition to this, like, so it's never going to hit the market, it's not worth your time.
Right.
And for sure, the data is kind of conditioned on that. I think that's okay, because what we're going to look at is what's happening inside the process. And there may be some of that in in our publication processes too, right? Like you and I have all gotten solicited to like review papers that we thought were just totally bonkers, but some of them, there's probably a large installed base of those things that never show up. I'm happy to talk more about IETF. There's so much more here. I'm never going to get through it all, but like, this is kind of a standards oriented crowd. So these are good things to spend some time talking about. Like, are there other questions in the?
Joanna has.
Just the phrase, the mantra, rough consensus and running code is going through my head, and that might help people who don't know about the system. This was in '92, they articulated this as sort of their guiding principle. So rough consensus, which is less consensus than, for example, ISO requires.
Yes.
And then running code means you can't make something a standard without it being running on existing hardware in at least two different places independently that can then interoperate.
So to be clear, we're looking a little bit at the pre-running code phase of IETF standards development. So Joanne is exactly right. they pioneered this like idea of rough consensus and running code. So the IETF was an evolution in the broader model of standards development. There was the old school world. You should go read her book about ISO and kind of standardization that goes back to the early days of the electrical and chemical technical industries. And there were formal committees with essentially, kind of supermajority voting rules. The IETF loosened it up, and one might sort of say open source is an organizational model that extended kind of the evolution from the IETF was the precursor of open source, which sort of moved, took advantage of the tools being developed at IETF to sort of change the paradigm for standardization. One of the things that the IETF did relative to the old school approach was to sort of say, we're going to do rough consensus and running code. Rough consensus is exactly the process we're studying here. The way running code works is after something is published as an RFC, it can advance from being a proposed standard to being something called a draft standard and then an internet standard. We don't look at that in our data, but to become a draft standard, there's a rule that you have to have multiple independent interoperable implementations. So you have to put it in product. They do all these cool things. They have things called plug fests where vendors come together and like with their beta versions of these protocols, and they kind of connect their hardware to see if it works. There's actually a facility up at the University of New Hampshire where they do a lot of this stuff. It's like kind of a neutral facility where people can bring their product, and like they protect the proprietary pieces of it, but they have test suites that they run to see if the standards are actually functioning. So yeah, this is the getting the first bit of consensus stage, right? Like in agreement on basically how we're going to try and put a standard into practice. But we haven't tested it yet to see if it's really, kind of functional at scale and successful in the market. Okay, so let me tell you then, like our data is essentially this. Like, so I said they have these repositories. The repositories literally are just like all of the standards, sort of as ASCII files. Okay, so I picked a famous one. This is the hypertext transfer protocol. Like, what do? We can sort of look at this and get a bunch of stuff off of it. We can get the authors' names and affiliations over here. Here's Tim Berners-Lee. We can get the dates when they published it. We also know when it's going to expire. You can see here, like this was published in July 97. It was going to expire in January 98 if they didn't either get published as an RFC or make a revision. We also can sort of see here, like, look, oh, this is draft IETF HTTP spec rev 00. So this is the 0th revision of the v1.1 HTTP specification. And so we can sort of parse these strings for many, many different proposals to understand how things evolve. Here's a different view of it. You can see kind of like, here's version 00, and then it got revised to version 1, revised to version 2, revised to version 3, until in this, in 98, they had the last call, right? Like we're getting close to consensus. This is like a last call for ejections. And then, sort of it goes through, it reaches publication. Okay. And so that process of revision, we think of revision as like a measure of investment in the idea here. And, kind of, we're going to look at how long does it take to reach success or failure.
So do you see the criticisms when they don't reach consensus, or we just see that?
Well, no, right? We have the email data, but we haven't done, I'm so excited by all of my junior colleagues' embrace of unstructured machine learning algorithms and so forth. But as a guy who's rapidly becoming an old timer, I have not gotten to that point myself where I convinced myself I can run those things on the email data and understand what's an objection or not.
Keywords. You can still do keywords. Keywords aren't so hard to.
So here's how the old timers do it. In our data, which will be a panel, damn it. The unit of observation is an internet draft version, okay, IT. And what we see for every version is an event. Like an outcome is going to be either we revise it, we abandon it, or it gets published. Okay. And then here's where we're going to try and pull in something to let us get payoffs, right? Like if we're going to model how these agents behave, we need some way of thinking about what their payoffs are. And this isn't awesome, but I think it's a path forward. And this is sort of the answer to Shane's earlier question. Like, what are we going to use as a payoff? We try two kinds of citations. One is we're going to look at the count of non-patent prior art references to this RFC, okay, or internet draft. We combine them. So we're going to find future patents that cite back to IETF standards and use that sort of as a measure of like commercial impact or some kind of amalgam of, you know, impact out in the world of the IETF standard. It turns out that there's actually a lot of these things are highly cited. I'll show you that. Alternatively, we've actually run the same models. We've used counts of references from future RFCs, right? Like in some sense, this is a cumulative endeavor, right? Like Shane was saying, the new stuff has to work with the old stuff. The most important old standards like TCP/IP receive thousands of citations from future IETF standards. And so
pi is citations?
Pi is citations. Payoffs are going to be measured in citations.
Can you cite an ID that doesn't get published?
Yes. I'll show you how big an impact publication has on citations. It's enormous, but we have both basically. And we have some stuff about the author team. You know, when did they arrive at the IETF? How big is the group of authors on this proposal? What's the experience, sort of who's the maximum experience of an author on this team? We have some stuff about feedback, like in the emails, we sort of really do it crudely, like the count of the emails that specifically mention this draft. And then we have some stuff about the size of the revision. So now what I want to do now, actually, let me show you the citation thing here, right? So I'll talk about the sample and then I'll show you kind of a descriptive analysis. Oh gosh, I'm gonna run out of time. So here's the full sample. It has in it 16,000 projects that went through 57,000 versions, okay? About 1/4 of these originate inside a working group, and about 75% come from individuals just submitting their idea. Okay, the average team on a proposal is about 2¼ authors that have about 15 prior projects inside the IETF. So these are people who do this a lot, okay? The average project gets revised 3.5 times, generates 21 emails. About 1/4 get published as RFCs, and it gets about 3 non-patent prior art citations from US patents. Okay, you can see broadly, everything is bigger, conditioning on starting in a working group. Okay, it goes through more versions. It has a higher, the probability of successful publication jumps to 56%, and it gets about 8 patent citations. Okay, if you condition on now standards track versus non-standards track, and sort of here's the standards track ones. We're going to say, sort of later on, we're going to kind of assume the non-standards track one all get published. The main thing I want you to notice here is look at the ones that get abandoned. They receive on average 3/4 of a patent citation. The ones that get published as RFCs, on average, they get 12.25 of these citations. So clearly, publications has a big hit on kind of payoffs. And there's more, it's not surprising. This is mechanical. There's much more communication about the proposals that succeed because they're being revised more and debated more, right? Like they go through more revisions.
But do publications sometimes include information that was in the abandoned one? So part of the citation difference is merely a transfer of the acknowledgement to a later proposal that's superseding the prior one?
Probably not, because with patent citations, you have a very strong incentive to cite the earliest possible prior art.
Oh, yeah, right.
Or else your patent will get invalidated. Yeah, this actually is something that comes up in like litigation.
Okay. Okay.
Okay. So now let me show you the 3 facts that kind of we use to motivate the formal model, right? So first thing, like this is the hazard rates. So here's the The dark line is the hazard of publication as an RFC. On the x-axis is the number of revisions. The dashed line is the hazard of abandonment. And the light dashed line here is the hazard of publication as a non-standards track RFC, one of those experimental or informational drafts. You know, basically what you see right away is a huge number of things are abandoned immediately. They just don't get traction. Okay. Second is the hazard of publication as a non-standard is uniformly higher, right? Like conditional on the number of revisions. Like we seem to publish those non-standards more quickly in some sense. Eventually, we're going to kind of use these as a set of controls where we assume no learning about consensus. We're going to sort of say, look, maybe it's the case that non-standards you can always get a consensus for something that's purely informational. So there's no learning about the kind of like, can I bring everybody around on the proposal? And we'll use that for identification a little bit. And then the other thing we see is this persistence, right? Like, so some of these things go for a long time. And we're going to use that kind of as part of the motivation for a model with two phases. I'll show you that in a model where all we do is learn about consensus, and the second we have consensus, publish. Kind of like you know, when the referees say I can publish my paper, you know, maybe I do a few tweaks, but boy, do I rush it back to the journal. Okay, we think that's not exactly the right model here, right? Some of them persist for a long time, and we think it's because they're trying to get it to be better.
So Ron has a question.
Yeah, I have a question about what exactly do the people working on the project learn when their draft don't reach consensus, and when they decide to whether to revise or not. And does that learning differ by projects? Do you observe anything from your data that allows you to learn from, like, for example, the email exchanges and so on?
Let me keep going a little, because so we're not going to use the emails in a way that you'll find 1,000% satisfying, but we'll show you that more emails is correlated with our model of coming up with faster learning. But recall what I said right at the beginning. With learning, you can't observe the things that are in people's head, right? Like the R&D productivity here is about how fast do we discover things about unobservables, right? So we need a model to put some structure on this. If we're gonna see how fast people are learning, we can't just see it in the data. We have to infer the learning from their actions. And here the actions are decisions to abandon, hence learning when to quit, or to revise.
So do you infer learning based on the decision whether people decide to subsequently abandon or keep revising?
We're inferring learning from their decisions about when they abandon and what's successful. Like fundamentally, I'll show you, we're going to write down a model, and a lot of what the model does is try to reproduce this pattern in the data, right? Like the hazard rates are a target of the econometric model that we.
Each one of these is independent of the other. So another point that Ron is raising is there could be an externality across.
Yeah, for sure. Like we're not going to have a model of learning across projects. Second, kind of stylized fact, conditional on publishing, okay, the number of citations is increasing in the number of revisions. Okay, so this is just fitting a regression model. We estimate this as like the log of the number of versions, and the dark line. So basically, there's an increasing. The more you're revised, sort of the more citations you get. I'm not attributing causality to this. I'm just saying, this is a strong correlation in the data. The things that are impactful in terms of citations, and this holds for both, IETF sites and patent sites, they tend to go through a longer process of baking. Okay, and then the last thing is the proposals themselves increase. They change over time. So this is a distance measure. So using keywords in the draft, like we see early revisions generate more change, right? There's declining marginal change in the language in the document over time. And so we're going to have a kind of a flexible cost function in our model that sort of can incorporate like, oh, if it's costly to sort of do a whole bunch of revisions, we want to allow those costs to be a little higher at the beginning of the process than at the end. Okay,
But you're not going to allow for those costs to be correlated within projects because each one of your P's is going to be separate.
Piece.
We'll see. Okay.
We do some stuff that allows for correlation within project, but it's not on the cost function. It turns out that it's fine to just allow it to be in this kind of a model. If you have like a correlation on the value function, you have correlation. So what we, sort of, we looked at that kind of those stylized facts about the process, and we thought like, so this seems like we need a two-phase model, right? Like, so first we see like the probability of abandonment going down and publication going up over time. So it seems like good news in a sense, right? Like, so bad news, pharmaceutical R&D is like a bad news learning process. You're trying and then, oh crap, like toxicology or whatever. Like, so you see dropouts for that reason. Here you see kind of, instead of that sort of thing, you see like, oh, they're learning that they got consensus. Like, we don't know if there's demand. This goes all the way back to, Shane will appreciate this. Tim Bresnahan said something that had this big impact on me 20 years ago at a conference in Wyoming, I think, about how like the fundamental problem of R&D is so different in pharma and in high tech, where in the former it's technological learning, in the latter it's the demand learning. And those are different, and that's a part of the flavor of what we're trying to capture here. So we're going to write down a model with these two phases. We're trying to learn about the good news of consensus. We never really learn, at the end of the day in this kind of model, whether we had a good idea for sure or not, unless we get to consensus. It's always the case that I could try again and rally people around it. In a sense, the two phases in our model are a little similar to this sort of stuff that Glenn Ellison did 20 years ago on publishing in economics, where he sort of talked about technical quality and polish. And, sort of he was showing us that polish has increased, dramatically over time. So our goals with this model, we're going to try to recover the following kind of primitives: something about costs, which we think of as opportunity costs here, beliefs about the quality of our ideas and how fast we learn. It's going to try to replicate hazard rates. The big challenge is going to be that we ourselves, we the econometricians, don't observe whether there's a consensus on a given project until it's terminated, right? Like, we only observe consensus when it gets published as an RFC, but participants in the IETF may know early on, like say they're in a working group, they may see consensus before I do. So this is going to be a model with a persistent unobserved state variable, which for lots of reasons generates econometric complexity. But it's going to be simple enough in the unobservable that we can sort of write down a likelihood function. Okay, so I'll try to go through this sort of quick. It's going to be a model where the team gets a project that's either good or bad. Okay, theta is an unobserved to us and unobserved to the team state variable. And the team can learn whether it has a good idea via what we call a breakthrough. Now, don't think of this as a technical breakthrough. We use the term breakthrough because in the literature on this type of learning, like there's a theory literature on learning, they call it a breakthrough. So this is connect to the theory literature. So this state variable here, sigma is 0 if you don't know, and it's 1 if you know that you got a good idea, which means that in every period, okay, we have to think about the transition probabilities on sigma, right? So the rate of learning is going to be B. Right? What is B? B is the probability that I get a breakthrough today, right? It's the probability that this state variable sigma goes from 0 to 1. Okay? But you can only get a breakthrough if you had a good project, right? If you had a bad project, the probability of transitioning to consensus is 0.
No false positives.
No.
Yeah.
Yep. So in every period, what happens? Team gets a cost shock, like, whatever, the drummer dies and the band breaks up, or or the cost shock is low, and so they can do a revision, and they make some decision to revise or to stop, right? And we can write down, because of the simplicity of the learning process here, what's their posterior beliefs given the number of revisions they've gone through, right? Their posteriors are just this function here. That tells me the probability that I think I have a good idea, okay, conditional on the number of revisions. And if I stop, here's my payoff. My payoff is sigma, which is to say I only get benefits if we've achieved consensus. If I've had the breakthrough, if we get the consensus, then I get pi, right? And pi is going to be something we parameterize based on the citations. Okay. Or, and I have an accumulated sort of cost function here, F. So every period I think about my costs, I decide whether to continue or not based on whether there's a consensus and what I think are the probabilities that going forward is futile because I have a bad idea. Okay, so what all of this means is that basically there's two stages in this model, right? There's an experimentation stage. It's a two-armed bandit, right? Where I'm trying to figure out like, hey, can I get consensus with this thing or not? If I get there, then Tim, the econometrician, doesn't know that consensus has happened, but these guys then face the second stage of the model, which is polishing. They just have an optimal stopping problem. Like I could make it better to get more payoffs, and that's going to depend on the costs of polishing it up. Or I could quit and, sort of put my proposal out into the world. Okay, so that's the game theoretic kind of setup. You could look at it this way, right? Like nature chooses whether the idea is good or bad. In the bad world, I just keep paying my costs until I decide to give up, right? Everything leads to minus F's down here. In the good state of the world, I have to experiment for a while until I convince everybody that there's a consensus around my idea. If I give up too soon, those are those false negatives, okay? Or I get to a consensus and then I start to get the pi in my payoff function. So that's the model. Let me show you in two periods so you get a sense of how it connects to the data. Okay, in a two-period world, you start here, you kind of get you put your proposal out there, you either get a breakthrough, like imagine it's a good proposal, right? It's good with probability P. You either get a breakthrough and you quit. So some share of proposals are published immediately. Or you get a breakthrough and you polish it up and you get to here. It could be the case that I didn't get a breakthrough and I quit. That's a false negative. So some share is abandoned immediately. And if I'm unlucky, I had a good idea, but I didn't get to, I missed again and the game is over because this is a two-period example, right? So the data here are these shares, right? What we're going to see is how many proposals succeed at 1, succeed at 2, fail at 1, fail at 2. Yeah.
So when you're learning about whether the project is good or idea is good or not, but then you also need to gather the consensus, convince people. Is there a strategy that you are taking, or you're just keeping it you're putting it up there and it's exogenous, whether there is a growing consensus and you're just observing it, or you actually may affect strategy in how you market it, how you convince people? And how does it look like in real world and in your model?
Totally. We're loading all of this into this like really reduced form. It's all just B, like the most interesting stuff about studying standards development all happens inside B. Like in the real world, we're debating each other and people are getting mad, like, coalition formation, like Cisco's talking to HP about like, if we both do this, can we pull Juniper Networks on board, or, Huawei, whatever, like all of that.
Yeah, and the issue is the coordination problem, right? If I'm not expecting that I can get others on board, then I'm not going to try. If I expect I can get others on board, then like this, the typical coordination problem. You're just sweeping it away, right?
This is reduced form, and in some sense, let me try to convince you that this is a contribution as opposed to a weakness. I think that people ask me, is standard setting about choice, right? So there's a long tradition in economics, including many theory papers, that say standardization is a process where people bring their technologies to the table and we choose, subject to increasing returns to scale, and so there's coordination. This is correct. There's also a long tradition of thinking about standardization as cooperative R&D. This is also correct, okay? How do we merge them? That is a great research agenda. This paper is taking the latter approach, which I would submit has been sort of underappreciated relative to the choice. Maybe I'm partly to blame for that. And so, yes, we're putting the coordination dilemmas and so forth all inside B, and just emphasizing, sort of, there's two ways to look at it. One is like, it's an impoverished model of standards development. The other way to look at it is it's a tractable model of learning in an R&D process that we could then apply not just to standard setting, but to say like learning about the quality of your business model in like a VC funding context, or learning about something else, right? So you either bought that or you didn't, but that's how I try to pitch this as a kind of a feature and not a bug. But yes, these are in the data, these are independent projects where we're just learning about consensus, where consensus is this interesting political construct that we kind of push into the background.
Yeah, right. It's learning in the community, but in some sense the community doesn't play a role.
The community's not here.
Yeah.
And it's one of the things we get every time with this paper is people saying like, you've got all this rich data on the emails, and which is all true. Like we could try, but like I want to make one step at a time.
Yeah.
Okay, there's the posterior beliefs. So what happens? What are the trade-offs? Before consensus, the trade-off is explore versus exploit. After consensus, it's just an optimal stopping problem. Like, are the benefits of polishing greater than the costs? Okay, it turns out, sort of like really quickly, this model in its simplest stripped down form, if you have a completely general cost function, is not identified. Why? Because if you say there's different costs on the two tracks, okay, in each period, then you have sort of 2T parameters, sort of the cost in every period, and P and B. And you really only have 2 times T data points, right? The share that stop or succeed in every period, right? And so you can the point here is that you can't do this like with a totally non-parametric cost function from an identification standpoint. We spend a lot of time on that in the paper. So we're going to take a couple of approaches. One is just to simplify the costs, right? Like, so we estimate, we say, look, if the revision costs just are a function of T and not a function of whether you've achieved a breakthrough or not, or we have a weaker version of the model, which is the revision costs are only they're a function of T plus one term, right? Like it's somewhat more costly, constantly more costly, or constantly less costly to do your revisions after a breakthrough. And then the other way we try to sort of deal with costs is we sort of say, hey, maybe there's no learning going on for these non-standards track proposals. Well, that allows us to estimate for a sample where without learning, we can just recover the cost functions of a revision. It's only polishing because you always have consensus. So we recover the cost functions from the non-standards track and then plug those in, and this can be totally non-parametric. And then we sort of estimate P and B from the standards track.
That's kind of a different sort of intuition.
It is. Yeah, it goes back to my job market paper, which did something pretty similar.
Right.
It turns out they generate very similar estimates, actually.
Really?
Partly because we can't get humongously tight precision on these learning parameters, but they come close. So to get a likelihood function, we do this as a finite, sort of very, very few proposals are revised more than 20 times, like a handful. So we assume that this is kind of a finite horizon game that ends after 25 revisions. And then that allows us to solve things backwards, right? Like, so just for those of you who are interested in like the estimation of this kind of thing, what we do is we take the patent citations, we estimate a log linear model of the citations, okay, to get this payoff function, okay? Then depends on whether we use the first or the second of those two kind of cost function approaches. But basically, we either get the cost functions from the non-standards track, or we just go right to step 3, which is iteratively, we're going to search for values of the 2 learning parameters, like the prior probability of having a good idea and the rate at which that's discovered, and the cost function, okay? And the likelihoods are going to depend on a sequence of cut points, right? Like there's going to be a sequence of cost shocks that are going to be too high and that would induce me to drop in each period. So you can iteratively go backwards, starting at period 25, compute all of those cut points and use those to create a continuation value. Okay. And from the continuation values, you can form the likelihood function. And the reason we can do this, even though there's like a persistent unobserved state variable in this model, is because the state variable is really just 1, 0, right? We can get the mixture distribution of success. Well, actually, it's the mixture distribution of failure, which are false negatives, and failures, which are true negatives, because we can just sort of track, sort of we can use these cut points to calculate likelihoods, keeping track of the share of proposals in each state along the way.
Can I restate this? Perhaps you'll find this useful. This
Yeah.
is how I'm understanding you. The reason you can identify this is because the thing you're trying to learn is whether it's a good idea or not, or the unobserved value.
Yeah.
And you're facing increasing costs over time, monotonically rising over time. There's no non-monotonicity here. That's what makes it work. So that as the costs keep going up, you can anticipate that, and you will eventually, by assumption, get to such a high cost that it's not worth your trouble. And so looking back, you can make a rational decision at some point to say, I haven't learned enough to know that I'm going to be above the threshold. Is that another way to think about it?
I would quibble, but I think that's fine. So the quibbles have more to do with like the non-convexity or the convexity of the overall problem has to do with cost benefit, not just cost. So as you'll see, the costs themselves fall. So to capture the very high initial dropout rate, the marginal costs of a revision are high, and they decline and they decline. But the benefits are declining too.
No, but they have to continue to. Yeah, there's at no point that you get to take away a cost. You don't get a. That's what I mean. There's no positive externality that then it's somewhere in the middle of this would generate non-monotonicity in total cost. Total costs are always rising.
Yes.
Yeah.
It's marginal costs that matter.
Yeah.
Period by period. But you're right.
Sure. Marginal costs can go all over the place. But yeah.
Okay. So this is, let me try to show you a summary. We do many versions of this in the paper, probably too many. But look, just the baseline, after you translate the parameters back into, kind of the probability space, as opposed to the way we have it parameterized for estimation, we get, 60% of the proposals are ideas that are publishable. You could get a consensus on this, right? But the rate of learning is 0.17, right? Like, so every revision, you only get a 20% shot of realizing consensus. And you see that the costs are dropping, sort of, the costs are high, but they go down. These are marginal costs here, not the total, just to clarify relative to our last discussion. If you look at the working group sample, it looks like, boy, learning is a lot faster, twice as fast, right? In some sense, that's not a surprise. Within working groups, there can be disagreement, but in some sense, we've already got agreement on this is an important problem that needs to be solved. Like, so a big piece of getting to consensus is in some sense resolved when you start out in a working group. And so an even higher share of ideas are consensus generatable, but it takes, and the learning is twice as fast as in kind of the non-working group set. If you look at the hazards, which I said we're trying to target, right? Here's the data, the hazards of publication and abandonment. And this is coming out of the model, right? And to be clear, we don't target the hazards directly, right? These are simulated hazards where what we do is we maximize the likelihood of observing, kind of, dropout or publication at each step. So it's kind of, I guess it's kind of like targeting the hazards, but I think we do a pretty good job. Then we do all kinds of kind of robustness and so forth. Like what, we allow for the payoffs, right? So the pie, these estimates are kind of, the projects are almost, ex ante identical. We treat all the projects as kind of just a realization. Now let's put some kinds of heterogeneity into this. Okay, one kind of heterogeneity is to allow the citation rates to vary systematically across the IETF 7 broad technology areas. So we do that. Another way to do things is to sort of move, everything right now is in version time, but we could try to put things in calendar time, sort of using monthly as opposed to revisions as T. So these, we do these, they don't have a huge effect on B and P. This one I'll talk about in a second. I think it's important. So here where we relax assumption one, we say, like, imagine that the cost function, instead of being identical across, post-breakthrough and pre-breakthrough, there's a cost shifter. You can think of this as actually a specification test of our two-phase model, right? When kappa here is really gigantic, effectively infinity, that shuts down the second phase in our model, right? Then it becomes just a model of learning, not learning and then polishing. And I'll show you that our model does better. We try it with step two, sort of, and then, one thing we do, because if you're worried about these sort of inter-project spillovers a lot, you think that that's generating bias or something like that, we thought, oh, within the working groups, let's remove all the later proposals and only sort of estimate this using the first proposal that's submitted or like realized within a working group.
So on that note, couldn't you also count the number of words? And in the first proposal, I mean, I realize why this is going to be hard, but you could do the first proposal, count the number of words and take the length, and that's a measure of complexity.
Mm-hmm.
So the more words you have, the more complex
the bigger is the project.
Right? Yeah, the bigger the project, and the fewer the words, the simpler the project. And then again, it's an X, and you can use it. It's
not, so the problem that there is an issue with just inserting X's here that has to do with estimation, right? Like, so this is not an easy setup in which to sort of incorporate lots of continuous X heterogeneity, but we're going to do that in just 1 second. So hold the thought. Okay. I'll show you at least the one of the ones I think are interesting.
Can I ask a question about that first point? I was actually coming from medical school where I was doing a project that actually turns out that estimating something. So I don't think I missed the piece. I guess the question is, can you do the estimation exercise entirely separately for the 7 different technology areas rather than like the equivalent of?
We could.
And so the reason I bring this up is this is happening in a project of mine right now, where it turns out it's about medical device innovation. It turns out that just having fixed effects for different product areas is different than like if you just break the data set up into, the equivalent of like a fully specified set of interaction terms, which is just like running the data only for each product area separately, gives you really different estimates by product area. And so I have sort of heterogeneity on the brain right now. No, but I think that where this is interesting is if you're thinking about like institution design or policy or something, it turns out it's really interesting. Like if you do get really different, you do get really different estimates across different technology areas, and that's potentially actionable information about institution design, right?
Mm-hmm. So I'll show you how I think this setup facilitates institution design questions in a different way. It's closer to a structural approach where you once you've estimated B and P, you think these are deep parameters and you simulate some changes in the world, which we can do here a little bit. As opposed to, we haven't gone down the path of tons of heterogeneity. But so I'm going to kind of keep going and I'll pick up the conversation with you about, I think sort of the econometric issues you raise are interesting, but for another time. So here's what happens if you kind of take out the second phase, right? Like we can't capture this increasing hazard, right? Like basically what happens is if you set kappa really high, if you assume that all that's going on here is learning about consensus, and as soon as we get to consensus, we publish, then what happens is the model sort of tries to pick P equal to 1. In other words, every proposal is good, and we're just sort of waiting until we get the breakthrough and, sort of something comes along. And, with learning, we get a very flat hazard of publication, and, sort of everything is about the costs. Whereas with learning and polishing, we can do a much better job of kind of replicating the patterns in the IETF data. Okay, so to summarize, sort of our estimates are pretty robust to a bunch of changes, and they tell us that about 60% of the projects are good, as in like, kind of they're publishable, but that it takes you a while, only actually 1/3 of these are actually published. That's the missing Donald Knuth's. And this sort of arrival rate of breakthrough or consensus is about 17%. And we think it's neat that, there's a large theory literature that has this kind of a Bayesian learning process, and we think we're the first to kind of go after it empirically. What you can do for people who care about the phenomenon, like this crowd, then, is say, hey, let's put in some heterogeneity. Shane wanted X's, I give you X's, okay? What we're going to do is put the X's on B or P or both, okay? And so we'll try 4. We're going to say, with team experience, what effect does that have on learning? Turns out it's going to be positive. With more email communication, also positive. I think of this one more as a correlation than a causal relationship, because the communication is clearly very endogenous to a lot of things.
Yeah.
This is kind of replicating a result from my job market paper. When there's more, when the sort of the working group is very diverse in terms of its suit to beard, when there's more suits than beards, like as it gets more commercial, especially at the very high end, that seems to slow down the learning rate. And we actually see no effect really of the size of the author team. Okay, so to do this though, we don't just put in X as like you would put it in a regression. The way we do it is basically we estimate, we make deciles or quartiles of X, and then we just estimate 4 B parameters conditional on X. Okay, because it just turns out that that's much easier for estimation.
Tim, when you say team size has no effect, that's sort of conditional on being a working group.
No, this is in the full sample, but. Oh, I see what you mean. Here, I mean, by team, I mean the number of authors.
So then maybe I didn't quite understand the distinction between an individual versus a working group. I thought an individual was an IP that was just one author, and a working group was an IP with multiple authors. Sorry,
I went too fast. Yeah. I think we use the word in the paper team, and it might be the wrong word, but team is the group of authors. So many of these proposals have 3, 4, 5 authors.
Okay.
That's what I mean by team and team size.
Okay.
Then there is a working group out there who interacts with these authors and makes decisions about is there a consensus or not. In some sense, the logical next step, I think, for this project, though hopefully not this paper, is to actually make some explicit assumptions and model like an interaction between the working group, or the listserv, the IETF, the other people out there who have to reach consensus, and the authors. And probably the way to do that is using the email data. It's to sort of say like, they are sending signals back, right? And this goes back to your question about how can can we turn an unsupervised machine learning algorithm loose on the email data?
Yeah.
Well, the one thing we do with affiliation is this one, right? Like, so commerciality.
Right.
So here,
like, that like something's at Microsoft now.
Right.
So the thing I want to know is like, if I write a proposal with Kiara and we work together now, but Kiara used to work with Shane, and Shane's part of the broader, like is not like that's stuff.
Right. The working group is like an invisible college, so it's visible in this case.
yeah.
Right.
Yeah, exactly.
But I think so that stuff, I think.
Yeah.
Like in scientific publishing, it's a thing, right? And and that would not necessarily be captured in email data. It might be correlated with what, like the likelihood that Shane and Kiara like exchange emails might be higher given that. But
we do have for authors, we really do have good affiliation data.
Yeah.
And so we've looked at it a little. We didn't find, somewhat surprisingly to us, a lot of traction with like variables on, are these 2 authors from different affiliations, right? Like it doesn't seem to matter for the outcomes we're looking at, even just correlational evidence, whether, this is an internet draft by a person from Microsoft and Harvard versus 2 from Huawei.
Yeah.
Because you would think that that might be a sign of consensus.
Yeah. Yeah. If anything, it's like that's sort of an interesting null result to the extent. Right?
The one thing we do find is so if you look at this column of results, right? So B category 1, 2, 3, 4. Think of those as quartiles in the distribution of, in column 4, the suit to beard ratio. So the share of overall essentially .com email addresses in the number of emails that are talking about this proposal or in the working group, right? So in it's actually kind of an inverted U. What we have here is like when there's no commercial people, learning is really slow. So it just takes us a long time to get success or failure. In the middle here, right, actually the learning goes quite fast. But then when you get a lot of .coms, right, the rate of learning, which is kind of basically capturing the speed at which we achieve consensus or not, falls off. Okay, which I think is, basically the fact, the data fact is the same fact that I published in a paper 10 years ago about what happens as the IETF commercializes. Like it takes them longer to reach agreement on proposals. But here we're filtering it or interpreting it through a parameter that relates to the speed of learning.
I humbly suggest suit to sneaker ratio. Just gendered.
You may indeed, and I've offered that caveat before, but I think we've entered the era when I should update my terminology. I agree. Although honestly, the IETF is not.
With sort of full recognition of like the fact that we're talking about a lot of dudes, I think it's still more.
It is a lot of dudes. There is a whole other. We have a paper about the effect of having, Emma and Bernard and I, and also some friends of ours have written a whole paper about gender and leadership at the IETF. And it is a paper I'm very proud of. It's also a fully guy author team, which is the most embarrassing thing about it. Yes. Okay. I wanted to show these because I think this kind of heterogeneity is like an interesting, that kind of stuff. But as a last thing, let me show you kind of how we think about these institutional design issues that you were starting to raise, which is.
So we got 7 minutes.
Yeah, let me just do two ideas and wrap, and then we can talk. So let's now take the baseline estimates of B and P and ask like a couple of questions. Right, one kind of question would be, what's Joanne saying?
She wants to know where the gender paper is published about the IETF.
They're not published, but you can find it on my website. One kind of paper is like, think about the classic incentives for doing R&D. Like if you step back and abstract this thing, you think of it as a model of learning or like, research productivity. We have 2 kinds of incentives that we give out: prizes and subsidies. Prizes being like patents, subsidies being like an R&D tax credit. So we can take our estimates and say, imagine that we're giving out, denominated in citations here, a prize or a subsidy, keeping the budget constant. How would these 2 policies affect the way people work inside the IETF? And holding all the assumptions of our model fixed.
So I would have thought of a different kind of action where you actually change the consensus formation. So you, instead of like a super majority, you actually reduce that threshold.
Totally.
A little bit lower.
But we don't have because we don't have a explicit formal model of consensus grounded in primitives. It's hard for us to do that.
Yeah.
So let me just give you the quick takeaway, which is I think interesting, and it's obvious if you think about our model for a while, but I wouldn't have known it sort of going in. Okay. In terms of gross citations that you generate, subsidies are great. Subsidies cause people to keep working, regardless of whether they have a good idea or a bad idea, regardless of whether they have achieved a breakthrough or not. Okay, so you get a lot of citations out of giving people a subsidy. Okay, it mechanically, neither of these is going to pay for itself in some sense, right? Because this is a single agent problem. The agents internalize all of the costs and benefits of their decisions. Like you can never generate, because we don't have externalities, which is Shane's earlier point.
Wait. But if budget comes through only Cisco engineers, then you also increase. So then you have conflict.
Yeah, hang on. So last point I want to make. We'll come back to that. So to get citation, if your only goal is to get a lot of impact, give them a subsidy. If you actually internalize the opportunity cost of the author's time, it's much better to give them a prize. Okay, right? Like, so this is saying the prize outperforms the subsidy because they don't, with a prize, they're internalizing this like, oh, maybe I've got a bad idea and I should quit and go on to the next thing. Okay. Of course, I was just saying, we can't have the policy pay for itself because this is a single agent who internalizes costs and benefits. But if you assume there are spillovers, which here is equivalent to saying, Shane, that Cisco values the citations more than the authors, right? So imagine that Cisco values the cites at twice as much as the authors.
Yeah.
Then you can derive what's the optimal prize to give an author.
If there's a branding benefit.
No, it's just because those citations are a measure of like how many routers got sold. And the Cisco cares a ton. Cisco's benefiting a lot more from that than the individual person who benefits only in terms of the glory they get in the engineering community. Right.
Okay.
So the takeaway here is, both of these things exist in the real world, by the way, right? Like, engineers have to get effectively subsidies from their employers to participate. Huawei gives out prizes to people who successfully publish IDs as RFCs. Okay, it turns out that in our context, given our model, prize is the way to go.
Deans give out raises to people who get these citations.
So here's the other one that I think is interesting and not obvious. Imagine over and under confident engineers. Which would you want? Okay, this is this graph shows that this vertical line here, this is the truth according to our model. What we can do is simulate what happens if you give them slightly wrong priors, right? Suppose you give them a pessimistic engineer, right? Like they think that their ideas aren't so good. It turns out that in this world, that's not that costly. Lots of bad ideas get abandoned, lots of good ideas get abandoned. They must be abandoned because there's some other opportunity cost of time. An overconfident engineer, like once they start getting really overconfident, that's tremendously costly. Why? Because overconfidence is leading them to just keep drilling those dry wells, right? Sort of they can go a long way down a path which is unproductive. Okay, and so in a world of sort of learning about whether you're going to get consensus on your idea, like a good news learning process, you really don't want to give them incentives to be overconfident. This kind of asymmetry in the costs of misaligned priors.
Yeah.
This is more about the model in some sense than about the data, but I think it's an interesting thing.
Well, because the model is asymmetric.
Yeah.
Right. I know. I hadn't thought of it. It wouldn't occur to me. No.
Okay. So you can see this in duration, right? Like, sort of being sort of pessimistic doesn't lead to huge deviations from what actually is going on, whereas being over optimistic generates like, real nonlinear effects in like pursuing bad research ideas.
This is trying to be the data. So is this something that generally applies to because of the model set or something?
This is like I was saying, I think this is a model driven type of result, but doing the counterfactual sort of informs us about the model a bit. And it also raises neat questions about essentially the kinds of mistakes that we make that lead to lower research productivity and which kinds are worse to make. Okay, so I'm at time, I think. Here's, the last thing I want us to summarize, right? Like, I think this is a paper that's partly about the IETF and standard setting and sort of reframing some of what goes on in standards development as exploration and technology development, which has always been there, but I think has been underappreciated, especially by economists in recent years, because we've focused on choice, because choice leads to the coordination dilemmas that everyone is interested in. Okay, so let's bring back the learning. That's one piece of it. Another piece of this paper is just about writing a tractable model of experimentation and learning that exploits these cool features of the IETF data, where you see the successful as well as the failed projects and the investment in both types. And so, here are the things that we think we learn. And, there's lots of directions to continue, I think, on this, especially, ones that you guys have raised, particularly around like, can we get more inside the committee and sort of model consensus generation itself and ask, institutional design questions around how high to set the threshold, or alternatively use the rich unstructured data to kind of build estimable models of the interaction between a community and a group of engineers trying to influence that community's views of the technology they're working on. So that's the project. Thanks so much.
That was awesome.